Hey guys, I got a question about week 2 Thursday, which is the linear and exponential week. So I'm going to go through that. This question has 3 parts and I'm going to do them one at a time. I'll start by reading the question and part A. A scientist starts with 100 bacteria in an experiment. In an hour, she discovers that the population has grown to 350. Part A. Assuming the bacteria growth has grown linearly over the first hour and continues to grow at that same rate, what will the population be in 6 hours? So there's 2 parts to this. The first thing is you need to write the linear equation, and then the second part is that you would need to substitute 6 in for x to solve. So things we need to remember when we're doing this is that a linear equation is normally set up y equals mx plus b, where m is the slope and b is the y-intercept. So in a word problem, m would be the rate at which it's growing, and b would be the initial value or the starting point. We also know that linear equations are like arithmetic sequences, and they grow by adding or subtracting the same number every time. So we were given 2 numbers in this problem, 350 and 100. If it's linear, then to get from one number to the next, you have to be adding. So to find what that rate is, what that number is, all we need to do is subtract 350 from 100. And we would also have to see if it needed to be divided by anything, but the problem tells us that this is over 1 hour. So we just subtract 350 minus 100, and it would be over 1, which would just end up being 250. So that is the rate at which it's growing. That would be our slope. So we have y equals 250x. And then the y-intercept is our initial value. Well, it says that a scientist starts with 100 bacteria in an experiment. So that would be our y-intercept. So it's plus 100. So for part A, we needed to have y equals 250x plus 100. To find out what the population will be in 6 hours, we need to plug 6 in for x and then solve. So we would have y equals 250 times 6 plus 100. And we do a little number crunching, and we find out that the answer to that is 1,600. So that is the complete answer to part A. Part B and C are both exponential. So these are going to be different formulas and setups. So part B says, which expression, it's multiple choice, which expression is an appropriate exponential model for the population of the bacteria? Let H represent the hours elapsed since the start of the experiment. So what we need to remember for this is what an exponential function looks like when it's set up, which would be y equals a times b to the x. So this is the general formula for an exponential function, where a is the initial value, or the y-intercept, and b is the base. In exponential functions, to get from one number to the next, you're multiplying. So with linear, you're adding, and with exponential, you're multiplying. It is like a geometric sequence. So to get our base value, we need to figure out what you are multiplying by each time to get from one number to the next. And again, the 2 numbers that we were given were 100 and 350. So we can get our base by dividing 350 by 100, which would be 3.5. So 3.5 is going to be our base. So we know that y equals a, whatever a is, we'll talk about that in a second, times 3.5 to the x. And again, we get 3.5 by doing 350 divided by 100. So the a value is our y-intercept, and that's our starting point, our initial value. It has the same meaning for linear and exponential functions and quadratic too. So again, we started with 100 bacteria, so that is going to be our a value. So our function should have been y equals 100 times 3.5 to the x, which with the options listed would be option D. And then they have some variations. A, B, and C kind of all look similar, but D is the only one that matches what I just showed you. Part C says, assuming the bacteria population has grown exponentially and continues to grow at the same rate, what will the population be in 6 hours? Give your answer to the nearest whole number. So we're going to get a decimal and we're going to round to the nearest whole number. This is, again, asking you to plug 6 in for x, just like the last time, but it's obviously going to work differently. So we should have y equals 100 times 3.5 to the 6th power. Now, we know, hopefully, because of order of operations, that we are going to do 3.5 to the 6th power first, and then multiply that answer by 100. And then my final answer for this, after we crunch some numbers and solve, is 183,827. So we can see the difference between when things are growing linearly and exponentially. And bacteria and viruses, kind of like the one that we're currently going through, they all grow exponentially, which is why, it becomes a problem so quickly, because you can see 6 hours for linear is 1600 and 6 hours for something that's exponential is 183,000. So, that would be week 2, Thursday. I hope that this was helpful. I hope that you're all staying safe and not working too hard. And I miss you guys, and I will talk to you soon. Bye. Leave me a comment, like, and subscribe. That's what Lily would say. All right. Bye.